everyone! This week what we're going to be talking about are a particular class of deductive arguments called categorical arguments. In fact, for the next 2 weeks we're going to be looking at a couple different kinds of deductive arguments, and so we're predominantly going to be working out of the logic appendix, not the textbook itself. We'll go back to the textbook once we sort of finish up talking about some examples of deductive arguments. The particular kind of deductive argument we're going to be looking at this week is a categorical argument, or an argument that concerns the relationship between various classes or categories. So, let's get started. Alright, so we've already said these categorical arguments are going to be examples of what we call deductive arguments. So that means that we're going to have a couple different concerns. We're going to want to figure out if the argument is sound, so a good deductive argument. And to figure that out, we're going to need to be concerned with whether or not the argument is valid, whether or not, if the premises are true, the conclusion also has to be true. So let's look at the example of deductive arguments we've actually been using since last week. Kara is a cat. All cats are mammals. Kara is a mammal. So by the end of today's class, we'll be able to, check my work and prove this is indeed a valid argument. Any argument with this form, it's going to work. The relationship that's being posited between Kara, the class of cats, and the class of mammals is such that, assuming those premises are all true, the conclusion also has to be true. Kara will have to be a mammal. To be a sound argument, we need to have both validity and true premises. So, are the premises true? Well, is it true that Kara is a cat?
Hey, Kara. So is Kara a cat? Seems the answer is yes.
Alright. What about, is it all cats are mammals? Is that true? Yeah, that's a biologically determined fact. So, we have true premises, we've got a valid argument, therefore, we've got a sound argument. So there are 4 different kinds of categorical statements. There's more, but we can sort of collapse the other ones into the 4. So let's go through all 4 of those kinds and look at some examples of each one. When we talk about categorical statements, we're frequently going to use what are called variables. We're going to not be talking about specific classes. We're going to rather talk about the general relationship that holds between different kinds of classes. And the reason for this is that validity is a formal notion. It doesn't really care about the content. So especially when we're talking about validity, it'll often be helpful to replace individual specific classes in the argument with variables that can stand in for any class. So our first kind of categorical statement is all S is P. So for example, all cats are mammals. And we're saying that every member of the class is present within the other class. We've also got no SSP, that there's no overlap between 2 classes. So, for example, no cats are reptiles. Right? There's no overlap between those 2 classes of things. We've also got some SSP, so some human beings are tall. Would be an example. Some human beings fit within the class of things that are tall. This is potentially troublesome, so let's define precisely what we mean by some, because, it can't be sort of a loose notion. Is it like 5 things? Is that enough for it to be some? Is it 10? For validity, we need to have certainty, so we actually need to really have a formal, precise definition of some. We're going to define some in this class as meaning at least one. So to say that some human beings are tall is to say that at least one human being is a tall person. And yeah, sure enough. We can also sort of translate claims about individual particular things, like say Kara is a cat. We can say Kara is at least one thing in my house is a cat. Which one? Kara. We can do the same thing with some S is not P. Some S is not P means that at least one thing in the S class is also not in the P class. So some human beings are not tall. Again, you point to me. I'm not a tall human being. I'm an average height for a guy. Right? And so it's true then that some human beings are not tall. At least one human is not tall. Me, if nothing else. So of these 4 different kinds of categorical statements, we can relate each kind of statement to all the other 3 kinds of statements and sort of know some things just on the basis of their sort of immediate relationships. We're going to use the square of opposition to visualize this. The square of opposition is something that was sort of come up with or sort of derived from the writings of the philosopher Aristotle. This categorical logic is actually one of the oldest kinds of logic, and it was basically sort of formalized by the philosopher Aristotle a very long time ago. So let's look at this square of opposition. just look at its parts first, then we'll sort of go through what all of it means. So we notice that on the top, we've got the two universal kinds of sentences. And by universal, we're talking about all or no. We're talking about every single thing in the class. Then on the bottom, we've got our two particular premises. The sum S is P and the sum S is not P. Here we're talking about at least one. Right? So we're not talking about all of them. We're just talking about at least one. We've also got sort of the affirmative and the negatives are in columns together. So all S is P is in the same column as some S is P. We're asserting that something is the case. Whereas no S is P is in the same column as some S is not P. This column is asserting that something is not the case. And so those are called negations. Each kind of sentence is related to all three of the other kinds of sentences. So let's go through these three kinds of relationships. First, we've got sort of the diagonal relationship. This is the relationship of contradiction. Two sentences are contradictory, or two statements are contradictory if both statements can't be true. Rather, one has to be true and the other statement has to be false. So if I was to say, all cats are mammals, we've said that's true, it's false then that at least one cat is not a mammal. If all of the cats are mammals, it's not true that there's one that isn't. That's what we mean by contradiction. Conversely, if we actually did find a cat that was not a mammal, that would make all cats are mammals false. That's what we mean by a contradiction. One has to be true, the other has to be false. The same relationship holds the other diagonal between the no SSP and the some SSP. Across the top, we've got what the relationship that's called contraries, or contrariety. Contrariety occurs where both statements can't simultaneously be true. So if you say all S is P and no S is P, both of those sentences can't be true at the same time. Let's look at a concrete example. All human beings are mammals. If that's true, no human beings are mammals has to be false, and vice versa. But they both, in principle, could be false in some cases. So let's switch it up a little bit. All human beings are tall, and no human beings are tall. Both of those sentences we've actually said are false, right? There are some humans that are tall, some humans who aren't. So neither universal statement is true. They both can be false, but they can't both be true. That's the relationship of contrariety. Go down, we now have the relationship of subcontraries between the two particulars. It's sort of the opposite. And so with subcontraries, both of the sentences can be true, but both of them can't be false. And then the last one we have is subalternation. This concerns the relationship between the universal affirmative and the particular affirmative, and then on the other side, the universal negation and the particular negation. And the way subalternation works is that if the universal statement is true, then the particular statement also has to be true. So let's just look at an example. If it is true that all human beings are mammals, then some human beings are mammals, right? Some just means at least one, remember. So if all human beings are mammals, then at least one is a mammal. If you want to point to that person, me. I would be an example of the one that's a mammal. Similarly, if no human beings are reptiles, again, true, I think we'd say, then some humans are not reptiles, also has to be true. At least one human is not a reptile. Again, which one? You point to me. I'd be an example. The opposite doesn't hold, though. We can't go from the particular being true to the universal being true. So it's true that some human beings are tall, but that doesn't mean that all human beings are tall. And we also can't go from the universal being false to the particular being false. All human beings are tall is indeed false, but it's not false to say that some human beings are. So this really only works in one direction. That's why the arrow only points downward. If the universal is true, we know that the particular also is true. We can actually do a whole class of argumentation just looking at these called immediate categorical arguments. We're going to skip over those, though, because of just basically the difficulties of the hybrid structure. So this would be one of the places we make a cut. All right, I think we're going to split these videos up in two. I think there's enough to count for that. So that'll do it for this first video. We're going to focus on categorical syllogisms, the main kind of arguments that we'll look at for these deductive categorical arguments in a subsequent follow-up video. So watch that one as well, and talk to you later. Bye.